All right, so one of the things you're going to have to be very comfortable with in chem class is this calculation between grams and moles, especially back and forth between grams and moles. That's going to get used a ton. And then initially here, we're also going to work in the conversion between moles and then a number of particles. And a particle is just anything, really. But in chemistry, we think of a particle as either an atom or a molecule, or if it's an ionic compound, we might call it a formula unit or something like that. So this is to help you to figure out how to do these conversions, all right? So the first thing we'll do is look at what we call the subway map. The subway map is just sort of a graphic representation of the way that this conversion has to happen. So if you have the grams of a substance, if you want to convert that number of grams into moles, you do so by dividing by the molar mass of the compound or the element that is in the problem. Okay, and then if you want to go back if you're starting with a number of moles and you want to go to grams, this is where you multiply by the molar mass. Okay, so that's pretty easy. That's the one that you have to be very, very comfortable with, and to be comfortable with that, you got to be really comfortable calculating those molar masses. So if you don't know how to do that, we gotta get you up to speed on that process before you start doing these conversions. And then if you are interested in going to numbers of particles, which you'll have to do for some of your initial homework assignments, you have to start at moles, and you can't go directly from grams to the number of particles. You have to do it from moles. So if you want to go from moles to the number of particles, this is where you would multiply by Avogadro's number, 6.02 times 10 to the 23rd power. And then if you are starting with a number of particles and you want to figure out how many moles that is, you then would divide by Avogadro's number. And it's just that easy. The only thing that makes this complicated is if you're you have a number of grams that you start with of something, and the question asks how many particles of that substance there are, and then you have to do sort of two calculations, but we can actually do that all in one big calculation, which we'll get to. So I want to start just doing a couple of quick questions with just this first part of the subway map. And this is the stuff you want to be very, very comfortable with. So here's a couple of practice problems we'll do. Here, this one says 2.85 moles of copper 2 chloride is equal to how many grams? And so here in this question, we're starting with a number of moles, and we want to go to the number of grams. And so to do that, we're going to multiply the initial number of moles, 2.85, by the molar mass of the compound. And so to do that, we got to figure out what the chemical formula of the compound is, and then we can figure out the molar mass. So copper 2 chloride is CuCl2. And when you add 1 copper to 2 chloride ions, we get a molar mass of 134.45 grams per mole. And now, what we try to get you to do is dimensional analysis to make this happen. So start with your cross, put this starting number of moles, whatever's given to you in the problem goes in this upper left, 2.85 moles. And then based on this, remember, we're going to be multiplying by the molar mass, right? And so we want the unit mole to cross away. We want to get rid of the mole value and be left only with the gram value. So this is the conversion factor, if you like, that equates the number of grams to the number of moles. So for copper 2 chloride, 1 mole is equivalent to 134.45 grams. And now it's just as easy as multiplying the 2.85 by the 134.45. And that answer, let's just do that one real quick, 2.85 times 134.45, and that gives us 383.18, and we are stuck with 3 significant figures here as a starting value, so we need to just round this to 383. So this is 383 grams of CuCl2. So that's pretty easy, just one quick calculation. I'll do another one just to solidify that. So here's the next one. This one will start with a number of grams of iron 3 oxide, and we want to know how many moles that is. So again, because in this conversion between grams and moles, we always use the molar mass of the compound. That's just something you should calculate right away, just because it's the most boring part of this, and you know, just get it out of the way quick before you set up the problem. So to do that, you got to figure out the formula. That's Fe2O3, and that has got a molar mass. Let's see, 2 irons and 3 oxygens would give you 159.70 grams per mole, right? Okay, now if we start with grams, all we're going to be doing really is dividing the given number of grams by the molar mass we just calculated, and that's going to give us our answer. Set it up with dimensional analysis though, please. So 73.567 grams. We want the gram unit to disappear. We want to be kept with the mole unit. So here, 1 mole is equivalent to that 159.70 grams. And now we can get rid of our grams, and now it's a division problem between the starting number of grams from the problem and the molar mass. And we'll just calculate that real quick. 73.567 divided by 159.70. And that gives us 0.46. We got how many sig figs? We got 5 sig figs we got to calculate here. So 0.46066. 0.46066. And we're left with that unit of moles. Okay, easy enough. That's working here in this little realm is again, like I said, it's pretty important. Now, if you're working with looking into the number of particles, then we got to bring in Avogadro's number, and you know, there's a way we can do this that's actually pretty easy, and you can sort of do it in one big problem. So let's do a couple of those. I have them. Here they are. Alrighty. Sorry about that. Okay, so here we're starting with a number of grams of sodium chloride, 36.87 grams of sodium chloride, and we want to know how many formula units that is. So that's a number of, you know, not molecules, because that's not how ionic compounds work, but yeah, so we're going to figure out how many sodium chloride units there are in 36.87 grams. So to do this, you can actually do this in 2 calculations if you want. You can convert the grams to moles, get that answer, and then convert that number of moles into number of particles. That's a little bit tedious, I think, so we're going to do it all in one big linear dimensional analysis problem here. And here's how that goes. We will do a table that kind of looks like this. It's got 3 places. And so we're going to put our starting number of grams here, 36.87 grams. Okay, the first calculation we need to do is from grams to moles. And so if we're just doing that, we would put our molar mass here and 1 mole here. And that's what we're going to do. But we're not going to stop there. 1 sodium and 1 chloride gives us a molar mass of 58.44 grams per 1 mole. So if we just stopped there, we would have converted the grams of sodium chloride into moles, but we're asked actually how many formula units, so we'll keep this problem going. Here we can use Avogadro's number, and we want to put that number up here, 6.022, 6.02. We'll skip the other two, times 10 to the 23rd power, okay? That is equivalent to 1 mole. All right, so now we've got a situation where we can cross off some units that exist on the top and the bottom of the fraction, and we're left really just with the unit of the, the counted unit, the number of particles. So really the math just looks like this. It's 36.87 times 1 times 6.02 times 10 to the 23rd. It's always good to put your Avogadro's number into parentheses. Some calculators will do this correctly, others won't. And then we're going to divide the product of this numerator by the denominator, which is 58.44. And then it's times 1. You'll end up leaving the ones out of this after a while. So really what you want to do is calculate the product of the numerator. So we'll type all this stuff in, 36.87 times, in parentheses, 6.02 times 10 to the power of 23. And I hit the equal sign right here. This number is then going to get divided by the denominator down here, which is really just 58.44, and that gives us a total number of formula units here that we're going to have to round to 4 significant figures. That's the value given in the problem. So this is going to be 3.7, oh no, 3.80 times 10 to the power of 23. Okay, so don't be afraid to calculate really large numbers of atoms or molecules. That's pretty typical. You'll get really large numbers when you are calculating that way. Here's another one where we're actually starting with a number of molecules, and we'll work our way back to grams. And so here, if you remember the subway map here, if we're going to look at this, we're going to be starting at this number of particles, which will then, divide by Avogadro's number to get to moles, and then multiply by molar mass to get to grams. We can do that in one problem, just like we did the last one. Okay, so here's how we start. We do our same kind of 3-part table. Start with our number from the problem, 7.21 times 10 to the 26. Now we want to convert to moles by dividing by Avogadro's number, and that's 1 mole. Okay, so if we stopped right here, we would have just converted this number of molecules into a number of moles. And now for the next part, where we go from moles to grams, we actually have to use the molar mass. And so to do that, we got to figure out what the formula is and then count it up. I know I said to do this right at the beginning, and this is why. You kind of get into the problem, and then you got to calculate the mass, and that's not as good as doing it in advance, I got to say. So the formula here is SO2, sulfur dioxide. That is 30, so a sulfur is 32.07 plus 2 oxygens. And that gives us a molar mass of 64.07. Okay, that's going to get used here to calculate into grams. So we want the mole value to disappear, so it's down here. I don't know why I wrote it all the way over there. And then it has a mass of 64.07 grams. All right, so for these numbers of molecules and things like that, sometimes I'll just use a little like number sign, because I don't know, it's nice to have a unit. Anyway, so the number unit crosses away, the mole unit crosses away, and we can multiply this number times 64.07, divide that product by Avogadro's number, and we'll be there. So the math looks like this: 7.21 times 10 to the 26th power times 64.07, and then we're going to divide whatever we get off of that multiplication problem by 6.02 times 10 to the 23rd power. Okay, it's always a good idea to enclose these scientific notation numbers in parentheses as you go. So I'll go ahead and calculate this together. This is 7.21 times 10 to the power of 26 times 64.07. And so that number, I just keep that number on the calculator. It doesn't mean much of anything. You don't have to round it yet. Just keep it on the calculator, hit the divide sign. And again, I'm going to enclose Avogadro's number in parentheses here. 6.02 times 10 to the power of 23. And that gives us our final answer in grams, right? So here, sadly, we're limited to 3 significant figures based on the stuff that we've worked with in the problem, the given value in the problem. So we're going to have to trim this number down to 3 sig figs. The answer that comes out on the calculator is 76735. And so we're limited to 3 sig figs. 76700 is your final answer, grams. Okay, it's kind of unsatisfying to have to round it that way, but that is kind of how you have to do that. Yeah, anyway, so that is those conversions. You got to be very, very good at those things. We'll do a lot of them. All right.